Bismillah ar-Rahman ar-Rahim. So this is the experiment of conservation of linear momentum. And as you can see in the photo, this is the setup we use to do our collision. This is an air table. This is a sheet of paper, normal sheet of paper. Underneath it, there is a sheet of carbon paper. We call this a puck. We have two of them. We'll make them collide with each other. There is a lot of friction between the puck and the surface of the paper. So we pump air through this air pump. It will pump air, and the air will go through the tubes. So the puck will be a little bit lifted from the surface, and we minimize friction. Also in this tube there is a wire connecting the spark generator. This is the spark generator. It is connecting the spark generator to a needle underneath the puck. So when you have a spark, it will discharge on the carbon paper, and from the bottom of the paper we'll see a mark. So when the pucks are moving, they will just create a mark for their motion. Here is a close look at the puck, and here is the tube. It will pump air, and it will there is a wire inside it, and this is the bottom view. And as you can see, there are holes that air will go out of them, so it will lift the puck a little to reduce friction. And here there is a kind of needle that the spark will go out of it, and it will discharge into the carbon paper. This is the air pump that we use to pump air so we can reduce friction. And this is the function generator, and as you can see, it is set at 10 hertz. What's the meaning of 10 hertz? Yani it will repeat the spark 10 times in 1 second. So let's have a look at the experiment in real time. So this is the top view of the experiment. Let's see. So this is the experiment. I did a collision, and as you can see, there is a trace of the moving pucks before the collision and after the collision. Now we want to analyze this collision. So this is the dots of the collision. So first of all, we write the information on our paper. So puck number 2, puck number 1, puck number 2. You write your name, your frequency you used, and the type of collision. We did inelastic collision. Basically, it's like this. Two pucks, they collide here. The first one will go this way, the other one will go that way. So we need to analyze. So first of all, we draw a line that will pass through most of the points. We will have some points that the line will miss, no problem, but we will draw a line that will go through most of the points. And then we choose our 2 points that we are going to do our measurement. We measure it. Let me enlarge the photo for you. So we measure it. It's here 22.5 plus minus half a centimeter. This is the distance. The time, we count how many periods. 1, 2, 3, 4. 1, 2, 3, 4. Period is 1 over frequency, so the period is 0.1 second multiplied by 4 periods. That is 0.4 second. We divide d over t to get V2 for the puck number 2. And as you can see, I kept so many numbers because I didn't calculate the error yet. You have to calculate the error in order to judge how many significant numbers you will keep. So that's V2. Then I go up, I calculate V2 prime. You need to repeat the steps D and T and then calculate. So I skipped it because already I illustrated for you. V2 prime. Prime means prime after the collision. After the collision. And then I go for V1. I put a line that will pass into most of the points, and then I do a measurement, measure the time and measure the distance and calculate V1, and then I go for V1 prime, V1 prime. Same thing. I pass a line that passes with most of the points, and then I figure out V1 prime. Prime means after the collision. Next, I decide for the x-axis. So let me just remove all those rulers so we can see better. I will just remove them. Okay. So this is my x-axis, the cross point between V2 and V2 prime, and the cross point between V1 and V1 prime. Those 2 points will determine my x-axis, and then perpendicular to it, I'll put my y-axis for both collision, and after that I put my theta 1 and theta 1 prime, theta 1 before the collision, and theta 1 after the collision, theta 2 before the collision, and theta 2 prime after the collision. And then after this, now I know V2, V2 prime, V1, V1 prime. I know the angles. So now I apply the analysis. Momentum in the x-axis should be conserved. So momentum before the collision must equal momentum after the collision within experimental error. And I analyze my momentum in the y direction, and also momentum before the collision in the y direction must equal momentum after the collision in the y direction, of course within experimental error. Thank you for listening.